Hello everyone, greetings of the day. Welcome you all for the 13th video of learning Swift programming language. So these are the topics that we have covered from video 1 to video 4, and these are the topics from video 5 to 8, and this from 9 to 12. Let's move towards the today's topic. The first topic that we are going to see is polymorphism. The definition of the polymorphism is the ability of a variable, object or a function to take on multiple forms. Let's see this in code. There are two types of polymorphism, that is compile time and runtime. The compile time polymorphism, let's see first. Method overloading is a type of compile time polymorphism. That is, see here we have defined a class of polymorphism and we have two methods here. The two methods with the same name of add, and the parameter names also same, A and B, but the parameter type is different. Both the methods returning, here integer is returning and here string is returning. So the method overloading in Swift is to define multiple methods. So here we have defined two methods within a class or structure with the same name. We have provided the same name as add, but with different parameters, or here we have provided the parameters of A and B and here also the A and B, or different types of parameters. See here the type is integer, but here the type is string. And here we have created an instance and here I am printing that. So here I have provided the value as integer 12 and 12. So if I execute this, I will get the answer as 24. For the same add function, now I have provided the integer value. So while the compile time, Swift itself determines, okay, this operation need to do. So for the same function, I'm just providing string. So in this time, Swift will diagnose that the parameter type is string. So I need to go with this method. So if I stop and execute this again, I will get the result as 12, 12. That is, both the string value got added. So this is the method overloading. While the compile time, Swift determines which method it need to compile and provide the result. That will be based on the input values that we have given. So this is the compile time polymorphism. The second type of polymorphism is runtime polymorphism, that we otherwise call as method overriding. See here we have defined a class of animal with the method having make sound, and we have inherited that animal to this dog class as well as this cat class. Both these classes already have the access for this make sound. Again we are overriding here, overriding the function that defined in this parent class and providing a different print statement for this dog class as well as for this cat class. Here we have created an instance, and that instances I'm adding into an array of animals. Here I'm accessing that. So these animals here I have been added in a for loop and accessing the property, the method of make sound. So initially the dog dot make sound will be executed, and then again with the cat dot make sound. So when I execute this, I will get the result as, initially for the dog this will get printed, and for the cat sound this will get printed here. So this is the runtime polymorphism. That is, we have created the instance here, and at the time of running it will choose which method it need to get executed. That is, here we have provided the method with the same name, but we are overriding in the child class. So at the time of execution here, that is, we are providing that animal.sound, that is, this animals array having dog as well as the cat instance. These two instances it is having, and at the time of execution doc.makeSound. In that case, it will go to this docs class, and here this method will get executed. That is, these all will be determined at the time of runtime. So this is called the method overriding. The method to be executed is decided at the runtime based on the actual object time. So here we have provided this object of dog.makeSound, and this dog is of the class of dog class. In that case, this method will be printed. This is the runtime polymorphism. So we have seen two types of polymorphism: compile time polymorphism as well as the runtime polymorphism. It will be having the same method, variable and object, and it will take different forms based on the requirements. That is, first one it is of the compile time it will take, and the next time it will on the runtime. The next topic that we are going to see is access controls. Access control means it restricts the access level of classes, structure, enum, properties, methods, and other entities within your code base. Let's see with example. There are 5 types of access controls: private, file private, internal, open, and public. Out of these, mostly we will be using this private access control. So let's begin with that. See here, I have defined a class with the name of bank account, and it has properties and method. Here I have made this property as private as well as this method as private. So the specialty of this private access control is it can be accessible only within this class, not from outside. So the private access control that we have provided to the properties or methods can be accessible only within this class and not from outside. That is the basic rule of this private access control. See here, this account balance I have defined initially as 0. We have an initializer for that. While initializing this class, we need to provide a parameter, and that will be assigned to this account balance. Here we have 3 methods actually. The first method, we have made it as a private as update balance. So whenever we call this method with a parameter, this account balance will be adjusted for that. Here we have a deposit. If we call this method with some amount, again the update balance will be called with this amount. So the account balance will be updated and the print statement will be printed. For withdrawal, again we have provided a got statement. That is, if the account balance is greater than or equal to amount. Here we will be providing the amount as a parameter. For example, if the account balance is 100 and the amount we are providing, that is for the withdrawal, if we are providing as 200 or something, then immediately the else clause will be functioned. That is, insufficient fund will be printed and exit from this function, or else this update balance will call. This update balance will call and the account balance will be adjusted, and then this print statement will execute. So this is the basic thing. And let's see how to call this. See here, I have called with this class. Here in this view controller, inside the view did load, this is our first screen. I have made this class instance here. Let my account equal to bank account with the initial balance of 100. For the initializer, this will be called. So the account balance will be initially it will be 100. Again, with this instance, I am calling the method of deposit. So then this deposit will be called, and then 50 I am adding it to it. So immediately the update balance will be called, and again here the amount balance will be 150 now. And then I am going for the withdrawal. this withdrawal will be called and will be printed. So if I execute it, I will get the result as initially for this deposit successful and the current balance will be 150. And again while doing the withdrawal successful and the current balance is 120. So this is the basic example. So here in this instance, if I try to access other than this deposit and withdraw, we have update balance and then we have this account balance as well. So if I try to access, it won't be available because we have made them as private. If I remove this thing and if I try to access, I can see the update balance. This is the beauty of private access control. So we will be having private access control. That's why it cannot able to access outside the class. See this account balance we have been used here and then here, as well as see this account balance we have used only within this class, that is here we have used, here we have used, and for this print statements we have used, not outside the class. The same thing for this method update balance as well, only within this class alone we have used, not outside the class. Also we have seen that the extension of a class means if there is anything to be added to this class after we have defined, we can add using this extension keyword. Extension of this bank account class, we can further add properties and methods to it. That is, for example, I have added the text function here. I have accessed the account balance and update balance. So these two are the private. This is the private property and this is the private method, but we can able to access outside this class if it is an extension of the same class. But here a clause is there. I have used the extension of this bank account and accessing here. The same extension if I access with another class. See, this is the class of view controller. Instead of accessing this extension here, see, if I access this, I will end up with error because it is saying that account balance is inaccessible due to private protection level. The same thing for update balance method is inaccessible due to private protection level. But we can use the other methods. For that there is no restrictions. If we want to use other methods like deposit or withdrawal, there won't be any errors will be showing. But if we try to access the private properties and methods outside the class, that is not in the same file, in the extension we have accessing means there won't be any issues, but outside the file, the extension if we try to access, it will end up with error. So summarizing as private properties and methods are to be accessed only within the class, and one exception is that if we are using the extension of that class in the same file, we can use that. But the extension of that class is in another file means then the private properties or methods we cannot able to use. This is about the private access control. See, the next access control that I am going to explain is file private. The same example I have taken here. Before this property and this method I have mentioned as private. Now these two I have made as file private. The file private means it will be accessible within this file. That is, here I have test view controller zip file. within this file I can able to access account balance. See here I have a class of bank account here. Even we have multiple classes in this file, we can able to access it. Even within the extension that we have mentioned within the same file, we can able to access. See here, I have an extension here. If I commented out and built, it will get succeeded. I have accessed the account balance and update balance. See, the account balance is file private, update balance is file private. See, this is another class. The first class we have mentioned is of bank account, and another class we have mentioned here as current account. Inside this view controller, I have defined this bank account class, created an instance and accessing the account balance and update balance. I am not getting any error to this. Let's check the scenario for this view controller file. In this view controller, again here in this view did load, I have created an instance for this bank account class, and if I try to access the account balance or update balance, it won't show for me. That is because for this file private, I can able to access only within this test view controller file here. Even the extension here, it will hit with an error if I build. See, account balance is inaccessible due to file private protection level. So that the file private, if we mentioned for the properties or method, can be accessible only within the file. Here this is the test view controller file. Only within this file, even we created n number of classes, in that classes and all, we can use this file private properties and method, as well as in the extension of this bank account that mentioned in the same file, we can able to access, not in the another file. This is about the file private. The next access control that we are going to see is internal. This is a default one. Even if we use or didn't, that behaves similar. See, for this deposit method, we didn't provide any access control method, and the access level of this deposit is only within this project one. That is, anywhere within this module, we can able to use this deposit method. Likewise, here we have mentioned for the update balance and for the account balance as internal. The accessibility of this account balance and update balance also within this module only. So we don't want to explicitly mention properties and methods as internal, because it is behaving like an access control with internal. That is about the internal access control. It is default. The next access level that we are going to see is open. This open and public access level that we will be using very least, because these applications are getting into the advanced concepts, that when we need to create a third-party library kind of things, then only we need this open and public access control. But for an understanding on the high level, I'll be explaining here. When a class is marked as open, it allows that class to be subclassed to the other classes, as well as the properties and methods, if we marked as open, that can be overridden by the subclasses within the same module or from other modules. This is about the open access control. See here, vehicle class we have marked as open, and we have subclassed this vehicle to this car class. Here we can able to override its properties and method. Even though this properties and method we didn't kept as open, we can able to override here. But if we are accessing this vehicle from another module. That is, this is a project 1. If we are using in the project 2 or something, in that case, if we want to override this accelerate or double, in that case we need to mention it as open. This is about the open access control. And the last access control is public. If we mark a class as public, then it can be subclassed within the same module, not outside the module. This is about the public access control. In order to summarize the access control, I just listed the important points here. We have 5 access controls: private, file private, internal, open and public. So overall we can direct access it. I have mentioned in green color, and we cannot directly access that mentioned in red. So for the private, within the classes we can make the direct access, and allowed in extension defined in the same file we have the direct access, not in the extension or classes defined in another file. And for the file private, accessible to the entire file where we have defined, allowed in the extension or other classes defined in the same file, not in the extension or classes defined in another file. For this internal access control, within the project anywhere we can use, not in the another project. For open, we can subclass within the existing module, that is a project, or in other projects. Properties and method marked as open can be overridden within the module or other modules. Public, that can be subclassed only within the existing module and not from the other modules. This is about the access control. The next topic that we are going to learn is table view. We have seen this table view in when we open the messages in iPhone or emails. We have seen the contents that we have kept in a row wise, right? That is the table view. Let's see this in code. If we want a table view, we need to start it from the storyboard. See, here I have only one screen. If I need to have a table view here, again I need to go and press for show library and table. If I type table, I can see the 3 things here. That is, I can have the table view cell and table view controller. So if I want the entire page need to be a table view, then I can directly choose this table view controller. So in this case, the whole screen will be a table view for me. But if this is not the case, I want a part of my screen need to be a table view, then I need to mention initially with the table view. I need to drag and drop here, and after that this is a table view and I want a cell for this. Again I want to add the table view cell for this table view. This cell is the each row that we are going to duplicate, because we will be initializing one cell here and we are reusing that cell again and again into this table view. See, if I choose for table view controller, I'm getting a table view here. Inside that, I'm getting a table view cell. That is the Swift itself providing as a default thing. But if I want it as a part of my screen, then again I need to define the table view, and manually I need to get a table view cell. This is the initial setup. After creating the table view and the table view cell, we need to provide an identifier for this cell, because we are connecting only the table view with the view controller, not the cell. For this cell, we need to provide an identifier. See here, reusable identifier, because as I said, this one cell we are reusing for every rows. So with this identifier only it will be get mapped. Like this we can provide any identifier name for this cell. For now I am deleting this table view controller, and we are using only this view controller. As I informed earlier, this view controller is mapped here with this class of view controller. So I need to map this table view to this view controller. For that, again go with the assistant, and again from here this view controller, I need to map this table view. So I can select from the storyboard or else from here, control drag here, and we can mention that this is a table view. So if I hover, we can see that I have mapped this table view here, and then the work of storyboard is over now, so we can close that. The next things we are going to handle from this class. So what all the data we have required for this table view, how many rows we need to populate, and for in each row what all the data need to be populated, everything we will be decided in this view controller. Let's see that. This is the data that we have defined in this view controller in order to populate in the table view. In order to make the code clean, what we will do is we will mention the table view in a separate extension of this view controller. Mainly for the table view, we need to consider for the data source and delegate. So here initially we will be mentioning the table view data source, UITableViewDataSource. If you select this, we can know that UITableViewDataSource is a protocol, and the protocol needs some methods to satisfy that. So initially the number of rows, in the table view, how many rows we have been required, that we can define. We will be defining as 5 rows here, 1 2 3 4 5. So I'm mentioning as return data source dot count. Here this method is expecting an integer value that we can provide like this, or else we can hardcode as number 5 as well. Other than this, we need to provide cell for row. So initially we have provided how many number of rows that have been required and what need to be there in that cell, that we need to define. These are the two mandatory things for this UI table view data source. Here we need to define initially the cell. Here we can define the cell as, let cell equal to table view. Here we have defined our table view dot dq reusable cell. When you type the dq, we have two methods, dq reusable cell with identifier and for. We need to select this one. There is another method here, we should not mistakenly select that. So with dq reusable cell with identifier for index path, this index path is the row, here we are getting it. The identifier that we have provided for the cell we can reuse here. Reuse cell, this is the identifier we have provided for the cell from the storyboard, and we can return this cell, because here this is expecting a UI table view cell. Now we have defined how many rows we have been required, and we have defined a cell here. Now what need to be there in that cell, that need to be defined. For that we can use this text label, but here getting a warning that text label will be deprecated in future versions of iOS. As of now we are using this text label and entering like this, that is the data source of index path dot row. This will work, but in future updates of the iOS we need to be change this text label, that I will show you. But before this, what is this index path? If I print this index path, I'll be getting as I'm going to run this project now. The build will get succeed and I'm getting the index path here. The index path is a two-dimensional array. That is, we are getting as 0, 0, 0, 1 like this. The first thing is the section and the second one is the row. That's why we have mentioned here as data source inside the brackets index path dot row. So every time this cell will get called, this is the index path it will get chosen. So the first time it will be 0, so the data source of 0, that is the ABC, will be defined here, and the second time 1 2 3 4, that is we are having 0 1 2 3 4. That's why I have used here. So the index path is a two-dimensional row. In order to use this last component, we have used the index path dot row. For this first one, we need to go with the section that I will explain in separate. Here you see the number of rows in a section that we have taken. This whole I have been used as a one section. I'm not defined any sections here, so we are considered as we are having one section. In that section we are having 5 rows, that is 1 2 3 4 and 5. So we have considered this complete as a one section. We have not defined the section thing here, so that I will explain you afterwards. So this is the index path. Now in the alternative of this text label, how we can write this, that I'll show you. Here while we are writing, they have been showing that use UI list content configuration, so we can use that. UI list content configuration. We are defining this to this UI configuration content configuration dot cell. After this we are defining the text here, data source of index path dot row. We already defined the cell here. Now assigning this configuration to the cell. Cell dot content configuration equal to config. That's all. If we run the project again, it will work as the same. See, we have received the same list of data, but now we have used this UI list content configuration of Xcode. Instead of the text label thing, we have used this one. Now we have seen that we have one section, and in that section we have this much number of rows. That is, this complete thing we have considered as one section. Here in this table data source, we didn't mention about the section as of now. We have seen that in the storyboard we have placed one table view and a cell, and we have mapped that table view here and added a data here, and then defined these things, that is number of rows in section. In one section how many rows we are needed, that we have defined here, and in that row for each cell what is the data need to be there, that we have defined here up to now. Okay, now we need to mention about the sections. For that, again see number of sections, come to here. Here they are expecting returning an int, so I'm mentioning as I want 3 sections as of now. What is the title I need to provide for that section? Here we can see title for header in section and title for footer in section. We know that the header and footer, that is in the top the title will be there, that is for header, and in bottom it is for footer. So here it is expecting a string to return, so I'm mentioning as starting section and the section number I'm providing. Always the section number will start with 0, so I'm adding 1 to it. So this thing I'm returning here. As same for footer also we can define if needed. Title for footer in section. The same return, instead of starting we can mark it as ending. Now we have defined that we need 3 sections. In that 3 sections this much rows will be there, and after that for each section we are providing the header as well as the footer. When we run this in simulator we can see that, see, as we mentioned, we need to have 3 sections and each section this much rows will be there. So we are having this rows and the section starting from section 1, that is 0 plus 1, and then ending by 0 plus 1. So this is one section starting from here and ending. So this is one section. Again we have 5 rows are there. Section 2 is starting here. Again we have 5 rows, and then the section 3 is starting here and ending here. So now we have 3 sections. Each one have a header, title for header and footer, and then each section is having 5 rows, and what all there in the 5 rows is defined here. So these are the major methods that you want to know in UI table view data source. Also, if you done everything and if doesn't reflect in the simulator means you may forget this one. TableView.DataSource equal to self. This is an important thing you need to add, because even whatever the methods you have written, this table view delegate you need to make. Data source and delegate you need to make. See here, I have selected the table view, and here you can see that it has been marked with the delegate or not. See here, we have data source and delegate. This data source we have marked with the code. So there are 2 options to make it. See, control and then dragging this table view to the view controller. If we release this, we'll be asking that you need to link with the data source or delegate. So already the data source I have accessed with the code. Here I am adding the delegate. Even if you want the data source, again you can add from here itself. This is the major thing in order to reflect in your code. You may be doing everything correctly, but if you miss this step, it won't reflect in the simulator. So already I have added that data source and delegate in the storyboard itself. So I don't want to again mention in this view detail. Now we have seen the methods available for the UI table view data source. Now we can see the UI table view delegate. That is, these are the data that we have added, like how many rows, how many sections and everything we have added. But in order to make changes to the appearance of the table view, we need to go with delegate method. For that, again an extension I'm adding. Even without mentioning an extension, we can add here itself by adding a comma to this, and we can include the other protocol, and we can add the methods for that. But in order to make our code clean and you need to distinguish between the data source and the delegate, I'm marking it as a separate. So here UI table view delegate. So this is the protocol we are adding, and the methods for this is not mandatory in order to have this protocol, but we can add the height. We have added the header and footer there, so we can add the height for that. Similar for footer, we can add. And if I just run in simulator, you'll know the difference of the heights. See here for section 1 I have added for 50 points, and for the ending section, see I have added 100. So based on our requirements, we can add the height for header and footer from this delegate. And one thing, when we click on these rows, nothing is happening. So if we want to do something when we click on this, if we need to move another screen or something need to pop up or something, we need to define in the did select row. That and all will be explaining in this UI table view delegate only. So I am adding the did select row here. So the table view did select row. So just printing the statement here. When I want to click something, I want that which rows I am selecting or which section I am selecting will be printed in the console. I have selected index path dot section and index path dot row. We can mention. If you have multiple screens and if you want to navigate to any particular screen when we select on the table rows, that also you can do from here. You can write the perform segue and move to the next screens. I just want to print in my console, so I'm executing this. See, it got loaded, so I'm clearing the console here, and when I load, if I select this, I have selected 0 section and 0 row, 0 section and 4th row I'm getting. So if I select this, I have selected section 1 and in the row 4. So this is the did select row. If you want to add height for row also, you can add here. So for every row you want the height of 20. Now I didn't provide any heights for the row. That's a default height that we are showing. If you want to provide any heights also, you can mention here. That is the appearance wise, whatever the things you want to do, you can do with the UI table view delegate, as well as the did select row also you can do. See, when I do that, my rows get smaller. So I'm increasing the size, whatever the size we have required, we can increase here as well. This is the UI table view delegate. See, this is the 50 I have provided here now. One more important method that you want to know in this UI table view delegate is view for header section. This is the same for providing title for the header section. That is, here already we have provided the title for header section and here the footer as well. But we can't do any customization here. That is, if we want to do any background color for our sections, or if we want to make any changes for this title, nothing can be do with this title for header section. So we are removing it now and adding the view for header section in UI table view delegate, and this is expecting a UI view in return. So initially we have added the header view. In storyboard we have selected the object library and added a view. The same here we have added in our code. So in the UI view, the height of this view need to be 50. We are adding the background color as light gray, and we are creating a UI label. This label also from the storyboard I have shown before. From the object library, again a label we can drag and drop there. Here I have added with the code. For the UI label, again I'm providing the height as 30, and then what need to be written, section, and then based on the section available from here will be printed here, and the text color we have provided and the font also we have mentioned, and for this header view we are adding this title label as a subview and we are returning the header view. If I run this in simulator, you can see that the sections will be clearly marked with the see section 1 is in bold, the size is 16, and then the background color we have mentioned as light gray. So this is how it will be shown. Section 1, section 2, and the section 3 is clearly defined with the help of view for header in section. As same view for footer in section also will be available. Just for an example, I have taken only one thing. So these are the major methods that you want to know in the UI table view delegate. The UI table view delegate and UI table view data source we have seen, and one important thing is we need to map our table view with the delegate and data source in order to reflect these changes in the simulator. Basic things about the table view we have seen so far. Let's see some more extra. See here, for the each rows we have seen the underline here, right? For each row is segregated by this line. If we want to customize that, we can do from here. We can select the table view, and from the right hand pan here you see the separator. This is the separator for each rows. We have kept it as default. If we kept it as a none, then if I stop the project and rerun that, I won't see any separators for each rows. See, no separator for each rows will be like this. So this separator is the part we need to select for. In default, it will be in the default. That means the single line will be provided for each rows. If we want to add any colors for that separator, we can do from here. And then separator, and then the separator insect. This is automatic. If we made as custom, the left and right we can set. That is from the left side how much distance it need to be, and from the right side how much distance it need to be, and all we can set from here. So these are the customizations we can do based on our project requirements. As I said before, this table view we are using for messages, mails, and most of the places in our iPhone. But when you see that rows and all, you'll be seeing that left side one image will be there, and then the title will be there, and then right side some icons will be there to navigate. So like that we'll be seeing for each cell. So likewise, that cell also we can customize in this table view. See here now the table view, how we can customize that we have seen now. If we click on the cell, you'll be getting that accessory. So this accessory we can able to provide. So if we want the disclosure indicator, so like an arrow mark will be provided for our table. If I rerun this again, you'll be seeing that for each cell we'll be getting that disclosure indicator. But if you see here, but if you want more customization, we can able to define the cell itself. See how we can do that. For that, I'm adding a new Swift file here. This Swift file is a CocoaTouch class. I'm clicking on the next, and I need to create a UI table view cell. See here, UI table view cell I'm selecting, and new cell, that is a name I'm providing. Also you need to click on this checkbox. Also create zip file. This is the file where we are going to design our cell. We can customize and design our cell where and all required we can able to design. So you want to click, and the language is Swift, and if we click on the next, we can create it. See, Swift itself providing a, this is the place where we can design our cell, and this is the code file that provided for the cell. See how we can customize the cell. So here again I just want to add a view so that I can provide some colors to that. So I'm just providing a view here, top 0, left 0, bottom 0, and the front I'm providing as 30 points, and if I click OK, it will assign here. I'm providing a color for this, any colors we can provide for, and then I just want to add more spacing in front, so I'm providing as 50, and again I want to add an image view in front. So in that case I'm just providing an image view and adding the constraints as I'm providing the width and height property. So 30, 30, that is the two constraints I'm providing, and that need to be vertically centered in the container, and we can mention this, it need to be 10 points from the label what we have defined, that is the constraint here leading of this view. This we need to have 10 points, so this point is 10, and then the height and width we have been mentioned. So what is the image required? So if we have any image we added to the assets, we can do that. So I'm just providing this image for now, or else any image you can select from here. So whatever the image you can select from here. If you want to change the color of that, you can change the tint as well. And for this label, for this view I'm adding a label here. I want the label to be horizontally and vertically in the container, and then I'm providing as 12 size, that's all. And this label I need to map with the new cell code. See, as I said, Swift itself providing us this code, so we don't want to explicitly map that, so just control drag here and provide a name, cell label I'm providing. So in the design file we have designed our cell image view, and a view I have added, provided a background color for that, and a label I provided. That label I'm marking here. Okay, so the job of storyboard is over. One more thing, we need to provide an identifier. As I said, for every cell we need to provide an identifier. See here, so we use the same name, reuse cell, the same identifier we provide here as well, because that cell we are going to delete and we'll be using this cell now. So I'm using the same identifier name as reuse cell, any name we can able to provide. And I'm coming to this view controller. So first of all I need to define that cell here. For that, table view dot register, I need to register, see, register the nib. Okay, and the nib I need to provide is UI nib. It need to have a nib name as well. This nib name is the file name. Here I have provided as new cell, right? So without any typo we need to provide the nib name. The bundle we can provide as nil. Then the identifier name that we have provided as reuse cell. We need to make sure no typo, even the capital letters we need to use as it is. So here we have registered our cell. Here is the place where initially we have defined what the cell is. We need to typecast here to the new cell. After that we can hide this for now and cell dot. See, the cell label is the thing that we have mapped in the new cell code. Cell label dot text. This need to be data source of index path dot row. Okay, and again if I reach here, I'm just providing that separator thing. See, the separator I'm providing as null, so I'm just providing the separator as single line. And if I run the code, I will get the cell design as like this. Furthermore, even we can design by providing corner radius for this view. See, I have added one more message view, UI view added to this code here and provided the corner radius for that and adjusted the constraints here. And if I run this, I will get the cell as, so as per our requirement and designs, UI designs, we can furthermore customize based on our needs. So this is about the table view and the design of cells. With this, we are wrapping the session for today. Thank you.